Okay, so here in this video we're going to look at a system h of t and x of t, and then we're gonna convolve these two to get an output y. Then we're going to sketch y for the case when y of t is equal to 1. So the first thing you want to do is you want to draw x of t. And this right here is a description of our x of t step function, u of t right there in red, and then we're subtracting u of t shifted to the right by 4, and you get this result right here. So then what you want to do is you want to draw your h of t in the tau domain, e to the negative at, so it's exponentially, infinitely approaching 0 but never getting there. And then here we want to draw our x of t minus tau, and we're going to flip it and shift it by t. Now, these are just standard steps you do when convolving two systems, a system with a response. So first thing we want to do is we want to look at the range where our x of t minus tau, where t is greater than or equal to 0 and less than 4, because that's our width of our x of t. That's our width of our x of t over here. So it's kind of, just draw it right here, t and t minus 4. So we're kind of varying our position of this whole x of t system here, function, and by the time t minus 4 gets to 0, it will be completely encompassed. So we want to look at that range, and we're gonna do the integral here from 0 to infinity, because we don't care about negative infinity because our step function does not exist there. So any integration, whenever you find the area of that, it'd be 0. So we do not care about that. So we're going to integrate 2e to the negative a tau d tau. And that will look like 2 over negative a e to the negative a tau 4, 0. I'm sorry, this is supposed to be, that's supposed to be t to t. And so what that will equal is, this is a constant, so you can pull that out. So you got that right there for your first domain for t is greater than or equal to 0, less than 4. So let's go over here, let's write it out. We've got our output when convolving these two together is 0 for t is less than 4 because of the step function. And then it's 2 minus a for e to the negative a t minus 1 for this whole, where t is greater than or equal to 0, less than 4, for that area right there. Now we want to look at this where t is greater than or equal to 4. So we want to look at this area where we've moved t over there. It's greater than or equal to 4, and then this is t minus 4 right there. We've shifted it. And we want to keep going with it, with t this way, until this hits this point. And then if it goes past that point, there's no overlap. So the convolution would, this does not exist past that point. This still exists, but this has no area. There's no value there, so we don't care past that point, because if we were to integrate it, if we were to find the area, it would be 0 times whatever this area is, and that would be 0, so we don't care. So we just need to look at this point at where t is greater than or equal to 4. Okay, so let's zoom out and let's integrate that. Let's write the integral for that. So we got t minus 4 to t for 2e to the negative a tau d tau. And so that's going to equal pull the constant out, we can just leave that out, e to the negative a t minus 4 minus e to the negative at. And so we want to write that over here with the rest of this, so we have our complete overlapping piecewise representation over here. Sorry, I'm switching to blue here by accident. And this is for t is greater than or equal to 4. Okay, so now that we have this, now that we have all this right here, we can look at our second part right here. Sketch y of t for the case when y of t is equal to 1. So you've done the convolution now for the complete range where they overlap. So if a is equal to 1, you just plug 1 in for a, you're going to get y of t still equal to 0 for the first range. You're going to get 2, 1 minus e to the negative t for t is greater than or equal to 0, less than 4. You're going to get 2e to the negative t minus 4 minus e to the negative t for t is greater than or equal to 4. So now we'll plot this. And that plot won't exist less than 0, and it'll go to a value of 2. This is our output of our convolution if we let a equal to 1. So right here we can see it doesn't exist for less than 0. It jumps up to 2, and then it exponentially decays here. But it doesn't start decaying until it gets to 4. And then at 4, it decays and approaches 0 infinitely, but never actually gets to 0. So it would look like this. So we're going to jump up to 2. We're going to stay at 2, and we're going to decay. Probably not that bad. Like that. And this is for t. And this would be our point right there, 4. So now you have convolved h of t with x of t, and you've sketched the output where y of t is equal to 1.